All right, I didn't even say good morning or anything, so welcome. No one's really watching my YouTube videos, so I hope that this is going to be helpful and you're going to start watching this. But I'm going to do number 31. You're assigned number 32. Number 31, what it is you're looking for. So most things like Wolfram Alpha have now an implicit plot. So the way you used to have to do this in high school is you'd have to take and solve for y somehow, and then you'd actually plot y as a function of x. But here what it can do is it can plot this function for you without having to solve for y. And so that's called an implicit plot. Most packages can do this now, and so this is what this graph looks like. Now, right here on number 31, I'm looking at the point x equals 2, y equals 1, which is right here at this dot that I make. You're looking for the slope right here, and you want to find that slope without actually solving for y, which is maybe not even feasible or plausible. And therefore, these methods, like the implicit differentiation, is to get you that slope without having to do a whole lot of algebra. That's what you're doing. So I just drew a little tangent line so you can see that there indeed is a slope and you're looking for that slope. So we'll do the same thing as before. We'll take the derivative from left to right. So again, I'm being careful. 2x, I have a product here. X times the derivative of y, dy dx, is 1 times dy dx. I'm skipping some steps now, but you still have to bookkeep. Plus second times the derivative of the first, which is 1. Make sure you have your parentheses in front of a minus sign. And I put up a parentheses here. I really don't need it. But the derivative of y squared is 2y dy dx. And the derivative of 1 is 0. Now I'm going to plug in that point that they gave me. I'm going to label it out because there's so much bookkeeping here. X equals 2, y equals 1. I plug in. This is different than cleaning up and solving before because it's a lot easier because you get to plug in the point, which is actually the point. So that's why I said I'm really not interested in seeing your algebra because you can avoid it all by just plugging in the point, which is what you're trying to find. So x is 2. I plugged in x equals 2 everywhere I saw an x. I plugged in y equals 1 wherever I saw a y. And now I'm left with just something with numbers in it. So I'm going to clean it up, but I'm going to clean it up slowly so I don't make a mistake. So all I did here is I put the 2 times 2 is 1, 2 times 1 is 2. There's a sign change when I take off the parentheses. Now I can combine the 4 and the minus 1, that's a 3. I can combine these two. I have minus 2 uglies, that's minus 4 uglies. And then I solve for dy dx. So bring over the 3 to the other side and then divide both sides by 4. And so I get 3/4. And that, going back to my picture, that's reasonable because the derivative looks like it's positive because it's increasing and leaning to the right. And this line looks almost like a 45-degree angle. The slope of a 45-degree line is 1, and 3/4 is pretty close to 1. So it all looks like it makes sense. So yeah, these things can be a lot of bookkeeping, and you can lose track of what you're trying to do. So be careful.